So today we're going to talk about the product of powers rule when multiplying exponents. And basically the product of powers is this. Product is anytime we multiply two numbers together. So if I'm looking at the product of powers, then I'm multiplying two variables with powers. Example, if I have a squared times a to the third, well, understand a squared means a times a, and a to the third means a times a times a. So basically, a squared is a 2 times, a to the third is a 3 times. And what we have here is when we put them all together, a times a times a times a times a, that's 5 a's all together. And really, that's just a to the fifth. Now, to condense that, I would really just take those powers and add them together. So the rule becomes this right here. Anytime I have a product of powers, I'm multiplying powers, I end up taking the exponents, m and n, and I add them together. So in the example here, I have 2 plus 3 for my powers, and 2 plus 3 equals 5. That's where I got that a to the fifth from. Now let's look at this in some real life examples. The thing to keep in mind is we are still multiplying things together. So if we have numbers like we do here out front, I still have to take those numbers and multiply them together. So here we have 3w squared times 4w to the 12. So really what happens here, I'm going to multiply that 3 and that 4 just as I normally would in any other algebraic expression. And 3 times 4 would give us 12. And then what happens here when I have w, I'm going to write on the corner, w squared times w to the 12, I'm going to take and add those exponents together. So that's 2 plus 12, which gives me 14. So really this answer becomes 12w to the 14th. And that's again because I add those exponents together. All right, let's look at this one. We have negative 4n times n to the third. Now, this is a little bit tricky. Understand that just because I don't always have an exponent, it's understood. Just as if I don't have a number in front of this n to the third right here, it's understood that it's a 1 n to the third. Well, on this exponent, or on this n here, I don't technically have an exponent, but it's still there. I still have 1n. It's understood that that's a first power. So really this is negative 4n to the first times 1n to the third. And just like with the last one, I could take and multiply just my numbers together, which is negative 4 times 1, which would give me still negative 4. And then I multiply my exponents together, or I'm sorry, I add my exponents together. N to the first times n to the third is really taking 1 and adding it to 3. Because again, that's 1 n and 3 n's, and altogether that would give me 4 n's. So the answer here would be negative 4 n to the fourth. That would be this polynomial simplified. All right, here again is where we have some understood powers. We have xy times x to the fifth. There's no numbers here. It's understood that it's 1, so 1 times 1 will stay 1. But we do have an understood power for this x, technically to the first, and this y to the first. So again, we've talked about this before where we simplify only like terms. You can only put like terms together. So we can only combine the powers of the x's because the x's are the same. And if we had more y's, we would combine the powers of the y's as well. So really what happens here is I'm going to go ahead and multiply those x's together. That's x to the first times x to the fifth. And again, this is like saying 1x here times 5x's here. And that gives me a total of x to the sixth. So that's why it becomes x to the sixth. And when we don't have anything to combine the y with, it just comes down. It is y to the first, but I don't write it like that necessarily. So this would be the final answer here, x to the sixth times y. All right, let's try one more. We have several pieces to put together. This one we have negative 3 times 2d to the third times d to the fourth. Again, I just want to look at the numbers that I have. I always would multiply the numbers together. And this is in 3 parts. We have a negative 3 outside the first parenthesis, and then in the parenthesis, 2d to the third. And then outside, we have a d to the fourth. Understand this is still a 1d to the fourth. So if I'm multiplying numbers together, that's really negative 3 times 2 times 1, which is where I'm going to get a negative 6 from. So that's negative 3 times 2 is negative 6. So that's the number that's going to come down. And then I can combine my d's. So here we have d to the third times d to the fourth. And again, this is like saying d times d times d times d times d times d times d. So if we add them all together, that would end up with 7 d's, which is really why I combine 3 and 4 and get 7 out of that. So this is negative 6d to the 7th would be the final answer here. So hopefully that gives you kind of a brief idea of how to combine like terms when we're multiplying product of powers. Keep watching for more videos. I'll see you next time.